Hello students, welcome you all for the today's lecturing session on fluid power engineering. In today's class, we are discussing with the signal processing elements with the use of logic gates like AND gate as well as the OR gate system. Okay, so we all know that in the previous class we are discussing about what are the different types of gating systems like OR gate, AND gate. In today's class, we are continuing with the application of shuttle valve for the extension of cylinder, then examples of the OR functions, then application of twin pressure valve for the extension of cylinder. Okay. So, very first important thing before you go into the logic gates, first we need to understand what is meant by the shuttle valve as well as the twin pressure valve. That is very much important. Okay. First of all, what is meant by the shuttle valve? So, shuttle valve, it allows either of the two pressurized inlet whichever is greater from the sources. So, this is regarding to the definition of the shuttle valve. Okay. So, the shuttle valve, it mainly consists of three ports. The one, it is called A, B and C. Here A and B, it acts as the inlet port, and the C, it is called as the outlet ports. So, here the definition is saying like it allows either of the two pressurized inlets. Okay, either of the two pressurized inlet, that means there are two inlet ports. The pressurized air may be coming from inlet port A or inlet port B, or the pressurized inlet may be coming from both the inlet ports like A and B, whichever having the greater source. Then the ball will shifted to the opposite side and it blocks the other inlet port. Then airflow will going to flow from the inlet port to the outlet port. Then here output is produced at a point C. Okay. Then very important one, it is called shuttle valve. It also acts like OR logic circuit. Okay. It acts like OR logic circuit. That means any one of the input signal is fed into the shuttle valve, then output can be seen at the outlet port C. So, this is regarding to the shuttle valve. So, then application of shuttle valve for the extension of cylinder. Okay. So, this is the circuit diagram regarding to the application of shuttle valve for the extension of cylinder. Observe here what are the main parts are available in the circuit diagram of shuttle valve for the extension of the single acting cylinder. Observe here, it consists of two power button operated, spring return, normally closed direction control valve, and these two it is connected to the shuttle valve, and this shuttle valve it is connected to the single acting cylinder. I repeat, it consists of two power button operated, spring return, normally closed direction control valve, and it is connected to the shuttle valve, and the shuttle valve it is connected to the single acting cylinder. Why it is called normally closed? So, during the normal condition, here in the direction control valve, outlet port, okay, here the outlet port A and B, it is connected to the tank port T. Okay. So, it is connected to the tank port T, and cylinder it will be in the retracted position. So, this is the normal condition. Okay. So, in the normal condition, the outlet port A and B is connected to the tank port T, and cylinder it will be in the retracted position. There are two cases. Okay. Case number 1. Now, if the push button is operated for valve 1, okay, if the push button is operated for valve 1, then direction control valve, now it is shifted from normally closed condition to the normally open condition. Okay. So, now the direction control valve, it is shifted from normally closed condition to the normally open position. Now, the compressed air will flow from the inlet port P to the outlet port A. Okay. Then compressed air from the outlet port A, then it is entered into the shuttle valve. So, now this compressed air allows the ball to shift towards the right side, and this will block the inlet port B. Then compressed air moves into the blank end of the single acting cylinder, and this will going to extends the cylinder. So this is the case number 1. Next, case number 2. Now keep the valve 1 to the depressing position. Now apply the pressure on the push button of the valve 2. Now this direction control valve shifted from normally closed condition to the normally open position. Now compressed air will flow from pump into the inlet port P to the outlet port B. From the outlet port B, it is then enters into the shuttle valve. Then this path allows the compressed air flows through the shuttle valve, then it is enters into the single acting cylinder, and this will causes the extension of the cylinder. Okay, so this is case number 2. Observe here, if the push button is operated, now the direction control valve shifted from normally closed condition to the normally open position, then compressed air will flow from inlet port P to the outlet port B, then it is enters into the shuttle valve. The shuttle valve, in the shuttle valve, the ball shifted towards the right, and this causes the compressed air to flow into the blank end of the cylinder, and this causes the extension of the cylinder. So this is case number 2. Now if both the valve 1 and valve 2 are operated simultaneously, then also both the direction control valves are shifted to the normally open position, then compressed air will flow from P to A here and P to B here, then this will make the ball to exactly settle at the middle of the shuttle valve, then compressed air will flow from both outlet port A and outlet port B into the blank end of the single acting cylinder, and this will also causes the extension of the cylinder. Okay, so this is the working of circuit diagram of shuttle valve for the extension of cylinder. And I already told this shuttle valve, it acts as a R logic circuit. That means if you supply any one of the signal, okay, if you activate the any one of the signal, then compressed air will flow through the shuttle valve, and this will allow the compressed air flow into the blank end of the single acting cylinder and causes the extension of the cylinder. Okay, observe here 0 0 1 1 0 1 1. Now if there is no input signal, then output is 0. If any one of the input signal is produced, then the shuttle valve causes the extension of the cylinder. So this is regarding to the application of shuttle valve for the extension of single acting cylinder. Next one, examples of R function. So what are the examples? Observe here, R function using, that means the shuttle valve function using 3 2 by 2. So what is meant by the 2 by 2? That means 2 ports and 2 position. Okay, using 3 2 by 2 pilot line spring return direction control valve. Okay, observe here, it consists of 3 2 by 2 pilot operated spring return direction control valve, and all these direction control valves are located in the parallel condition. Okay, so all the 3 pilot operated spring return direction control valves are located in the parallel condition. Here the pilot line A, pilot line B, pilot line C acts as the inlet ports, and D, it acts as the output port. Okay, so what is the working? There are 3 cases here. If the direction control valve 1 is actuated by pressing the push button, okay, if the direction control valve 1 is operated by pressing the push button, then compressed air will flow through the pilot line A, then it will actuate the direction control valve from normally closed condition to normally open position. So observe here, in the normal condition, all the 3 direction control valves are in the normally closed condition. Okay, if you press the push button for first direction control valve, then the pilot line actuates the direction control valve and shift the direction control valve to normally closed position to normally open position. This causes compressed air to flow from direction control valve 1 to the outlet port D. Okay, similarly push button is pressed for second direction control valve, then also the pilot line shift the direction control valve from normally closed position to the normally open position. Then compressed air will flow from inlet port B to the outlet port D. Similarly, if push button is pressed for third direction control valve also, then this pilot line actuates the direction control valve from normally closed position to the normally open position. Then also compressed air will flow from inlet port C to the outlet port D. So this is regarding to the R function using the 3 2x2 position pilot line spring return direction control valve. Okay, observe here, very important thing, if any one of the 3 direction control valves, that means V1, V2 and V3, if it picks up the air signal from either A or B or C or all the 3 signals, then output will produce at a point D. So this is the first example of R function. I repeat, it consists of 3 2x2 spring return direction control valve, all are connected in parallel. Here A, B, C acts as the pilot inlet port and D acts as the outlet port. If the push button is operated for first direction control valve, this actuates the direction control valve from normally closed position to open position. Then the compressed air will flow from inlet port A to the outlet port D. Similarly, if the second direction control valve is operated by the push button, then also compressed air will flow from inlet port B to the outlet port D. And similarly, if the push button is operated for third direction control valve also, then compressed air will flow from inlet port C to the outlet port D. So very important thing we need to observe here, if any one of the 3 direction control valve picks up the air pilot signal, then output will produce at the outlet port D. Second function, R function using 1 2x2 direction control valve, that means 2 ports and 2 position and 2 shuttle walls. Okay, observe here, it consists of 1 2x2 direction control valve, that means normally this condition is called normally open position and this condition is called normally closed position. Okay, then this direction control valve, it is initially operated with the help of the pilot line or pilot air pressure, and it is deactivated with the help of the spring return, and it consists of 2 direction control valve. Here A, B and C are acts as the inlet ports. Okay, and in working condition what happens? If the compressed air is applied at the inlet port A, this causes the ball to shift towards the right position, then it will blocks the inlet port B, then compressed air from the inlet port A, then it is enters into the second shuttle wall. Okay, observe here, if the compressed air is applied to the through the inlet port A for the first shuttle wall, then ball shifted towards the right and blocks the other input signal B, then compressed air from the shuttle wall 1, it is then enters into the shuttle wall 2. Then it pushes the ball from the shuttle wall 2 towards the position C. Then compressed air from the inlet port, it is then enters into the outlet port of the shuttle wall, then it is enters into the direction control valve. This pilot signal actuates the direction control valve from normally closed position to the normally open position, then output can be obtained from inlet port P to the outlet port S. So this is regarding to the R function using the 2 shuttle valve and 1 2x2 spring return pilot operated direction control valve. Okay, I repeat, it consists of 1 2x2 pilot operated spring return direction control valve and 2 shuttle valves. Okay, then here A, B, C acts as the inlet ports and P it is acts as the inlet port of the direction 2x2 direction control valve, and S it acts as the outlet port of the 2x2 direction control valve. If the compressed air is applied to the shuttle wall 1 through the inlet port A, then this compressed air causes the ball to shift towards the right side, and this will causes the compressed air to flow from the shuttle wall 1 to the shuttle wall 2. Then this compressed air again causes the ball to shift towards the right side, and it blocks the inlet port C, and this will enters into the direction control valve through this pilot line. So this pilot line actuates the direction control valve. Initially it will be in the normally closed condition, then it is shifted to normally open position. So once it is shifted to normally open position, compressed air will flow from inlet port P to the outlet port S. Okay. So this is regarding to the shuttle valve, application of shuttle valve, and the examples of R function. So examples of R function, first one it is called using the 3 2x2 spring return pilot operated direction control valve, and second one it is called R function using the 1 spring return pilot operated direction control valve and 2 shuttle valve. Next, third one, very important one, it is called AND function. So before we are going on to the AND function, first we need to understand what is mean by the twin pressure valve. Okay. So what is mean by the twin pressure valve? So twin pressure valve also having the 3 ports, and A and B are acts as the inlet port, and C will acts as the outlet port. Okay. So the twin pressure valve also having the 3 ports similar to the shuttle valve. That means here A and B acts as the inlet port, and C it acts as the outlet port. Very important one, when will be the output is produced in case of the twin pressure valve? If both the input signals are fed into the twin pressure valve, then output will produce at a point C, and this twin pressure valve will act as the AND logic circuit. Okay. Then very important one, it is called the application of twin pressure valve for the extension of single acting cylinder, similar like application of shuttle valve for the extension of single acting cylinder. So observe here the parts remains the same. It consists of 2 power button operated spring return direction control valve, and this is connected to the twin pressure valve, and this twin pressure valve it is connected to the single acting cylinder for the extension stroke. Okay. I repeat, it consists of 2 power button operated spring return normally closed direction control valve, and it is connected to the twin pressure valve, and this twin pressure valve it is connected to the single acting cylinder. Okay. So next, here also there are 3 conditions. Now condition number 1, if the valve 1 is operated by depressing the push button, now this direction control valve shifted from normally closed condition to the normally open position. Okay. It is shifted from normally closed condition to the normally open position. Now the compressed air will flow from the compressor into the inlet port P. From the inlet port P, then compressed air it is enters into the outlet port A. Then this compressed air it is then enters into the shuttle valve. This causes spool to shift towards the right. Okay. This causes spool to shift towards the right, and this will going to blocks the outlet port C. Hence there is no extension of the single acting cylinder. Okay. I repeat, if the push button is operated for the valve 1, now this direction control valve shifted from normally closed position to the normally open position. Now the compressed air will flow from inlet port P to the outlet port A, then it is enters into the twin pressure valve. This twin pressure valve shifted to the normally towards the right side. Once it shifted towards the right side, this will going to blocks the output port C, hence there is no extension of the single acting cylinder. Similarly, if the push button is operated for the valve 2, then also this direction control valve shifted from normally closed condition to the normally open position. Now compressed air will flow from inlet port P to the outlet port B, then it is enters into the twin pressure valve, and this causes this spool to shift towards the left side, and this will going to blocks the outlet port, hence there is no compressed air enters into the blank end of the cylinder, hence there is no extension of the single acting cylinder. Now if both the push button is pressed simultaneously, or if both the push buttons are pressed together, then both the valves are actuated, then compressed air will flow from inlet port P to the outlet port A as well as outlet port B. Now this spool, it is exactly settled at somewhere at the center. Now compressed air will flow from outlet port A to the outlet port C. Then this compressed air enters into the blank end of the cylinder, and this will cause the extension of the cylinder. So this is called application of twin pressure valve for the extension of the cylinder. So, and also this twin pressure valve, it also acts as the AND gate, right? So 0 0 1 1 0 1 0 1, that means here 0 0 0 1. That means if the signal is fed simultaneously for both the valves, then only output can be seen for the extension of the single acting cylinder. So this is regarding to the application of the AND gate or application of the twin pressure valve for the extension of the cylinder. So the next topic, it is called the examples of AND function. Okay. So in the examples of AND function, we need to see the 4 different operations. So very first thing, it is called AND function using the 3x2 direction control valves. Okay. So very first thing we need to observe here, it is called, in this condition we are having the 3x2 direction control valve, and it is push button operated, normally closed, spring return direction control valve. It consists of 3 push button operated, spring return, normally closed direction control valve. Okay. So very first thing we need to observe here, it is called, here A, B, C are acts as the outlet ports. Okay. And here P, it is called as the inlet port, or it is called as the pressure port, and R, it is called as the tank port. Okay. So next, very important thing, it is called, observe here, if the push button is operated, for the valve 1, then what happens? If the push button is operated, then this 3x2 direction control valve shifted from normally closed position to normally open position. Okay. Once it is activated to the normally open position, then pressurized air from the port P, it is then enters into the outlet port A. Okay. From the outlet port A, it enters into the valve 3, and it actuates the valve 3, but there is no output at the output port C. Why? Because here very important thing, it is called, here the valve V1 and V2 are connected in such a manner so that only output is present if both the valve V1 and V2 are activated together. Okay. This is very much important. In case of the AND function using the 3x2 direction control valve, here the 2 direction control valves like V1 and V2 are connected in such a manner such that here output is produced at V3 only when V1 and V2 valves are activated together. Otherwise there is no output at outlet port C. Okay. Now observe here, if the push button is operated for valve V2, then this valve changes from normally closed condition to the normally open position. Then the pressurized air will flow from inlet port P to the outlet port B. Then this will send the signal to the valve V3, and this will actuate the V3, but again there is no output is produced at the outlet port C, because here now V1 is not connected together. Then if the push button operated for both V1 and V2 simultaneously, okay, then the pressurized air from the inlet port P, it is simultaneously enters into the outlet port A and the outlet port B. Then this will actuate the valve V3 simultaneously. Then we can see now this valve V3 changes from normally closed position to the normally open position, and compressed air will flow from port P to port C. So then only we can observe the output at the outlet port C if both the V1 and V2 are actuated together. So this is for the AND function using the 3 by 2 direction control wall. That means it again acts as the AND gate itself. That means observe here V1, V2 and V3. That means now if wall 1 as well as wall 2 it is not activated, then there is no signal is produced at the wall V3. If the wall 1 is activated but wall 3 it is not activated, then there is no output. Similarly, if the wall 1 is activated but wall 2 it is not activated, again there is no output. If both the walls V1 and V2 are activated with the help of the push button, then only we can observe the output at the wall V3 and pressurized air will flow from inlet port P to the outlet port C. Next, AND function using the tandem connection of 3 2 by 2 direction control valves. Observe here, what is meant by the 2 by 2? It is nothing but it is having the 2 ports and 2 positions. So then it is called normally open position and normally closed position. Okay, and here all the 3 2 by 2 direction control valve are connected in series, and here A, B, C are acts as the pilot inlet ports. Okay, and here D it is called output port. Okay, so observe here what happens during the operation. Okay, so very important thing, it is called, if initially or during the normal condition all the 2 by 2 direction control valves are in the normally closed condition. So initially they are all in the normally closed condition. Okay, hence there is no pressurized air will flow from inlet port to the outlet port. Okay, if the push button is operated for the first direction control valve, then it will send the signal to the 2 by 2 direction control valve. Now it is shifted from normally closed position to the normally open position, and then this pilot signal will push the compressed air into the second direction control valve. In the second direction control valve, spool shifted towards the right side, and this will going to blocks the flow, hence there is no output. Now if this second direction control valve is also activated with the help of the push button, then compressed air will also flow through the pilot line B, and this pushes the twin pressure valve exactly at the center. Then compressed air will flow from A to B, next it will flow from B to C. Okay, and the compressed air, it is operated with from A, then it will come to the second direction control valve, then it is come to the third direction control valve. Now if the push button is operated for third direction control valve, then it is shifted from normally closed position to normally open position, then compressed air will flow from second direction control valve to third direction control valve, and this will make the spool to locate exactly at the center. Then compressed air will flow from third direction control valve to the output port D, that is A, B, C. So very important thing you need to observe in case of the tandem connection, here all the 3 2 by 2 direction control valves are connected in series, and if pilot line exists in all the 3 valves, okay, if pilot line, that means A, B or C, if pilot line exists in all the 3 valves A, B, C, then only output is produced at a point D. If any one of the input is off, then there will be no output will be appear in the output port. So this is regarding to the AND function using the tandem connection. Next, AND function using the 2 3 by 2 direction control valve and 1 twin pressure valve. It is exactly similar to the application of twin pressure valve for the extension of the single acting cylinder. Observe here, it consists of 2 push button operated, spring return, normally closed direction control valve, and it is connected to the twin pressure valve. Okay. If the push button is operated for valve 1, then it is shifted to the normally closed position to the normally open position, then compressed air will flow from inlet port P to the outlet port A, then this will enters into the twin pressure valve. Then this spool shifted towards the right and it will closes the output port C. Okay, then this will closes the output port C. Next, if the push button is operated for second direction control valve, then this will shifted from normally closed position to the normally open position, then compressed air will flow from inlet port P to the outlet port B. Then this compressed air pushes this spool towards the left side and this will going to blocks the output port and there is no outlet at the port C. If both the push buttons are pushed simultaneously, then compressed air will flow from both inlet port to the outlet port A and B. Now this spool, it is located somewhere at the middle and compressed air will flow from inlet port, outlet port A and B to the outlet port C, then output we can going to achieve. So this is called as the AND function using the two 3x2 direction control valve and one twin pressure valve. So you can observe the logic gate A, B, C, okay, 0, 0, 1, 1, 0, 1, 0, 1. That means if the push button is not operated for both the valves, hence there is no output. If the push button is operated for valve A and it is not operated for valve B, then no output. If the push button is not operated for valve A and it is only operated for valve B, then also no output. If the push button is operated for both the valves, then you can see the output at a port C. Last one, AND function using only twin pressure valves. Okay, so AND function can also be achieved with the help of the only twin pressure valve, and here if there are n number of signals or if there are n number of input signals are available and all the input signals are I, then only we can achieve the output. Okay, and in case of the only twin pressure valve, if there are n number of input signals are available, then you have to use n minus 1 number of twin pressure valves. Okay, observe here E1, E2, E3, E4, E5. Here 5 input signals are available, but you need to use 4 twin pressure valves in order to achieve the output. And in case of this, here output is initiated only if all the input signals are available or all the input signals are higher, then only output can be seen. If there are any one of the input signal is absent, then output is going to 0. So this is for the twin AND function using only twin pressure valve. Observe here E1 signal is present, then twin pressure valve shifted towards the left side. If E2 is also present, then exactly at the middle. Then it will send a signal to the D, it will pushes the left side and blocks the flow. If E4 and E5 is present, then this will send the signal to the B. If B sends the signal, then it will make exactly to the center, then output is produced. Otherwise there is no output. If all the input signals are present, then only output can be seen, otherwise output will disappear. Similarly, this is the another condition, here all are connected in series. If E1 and E2 is present, then twin pressure valve A, it is located at the center. If E3 is also present, and then it will be the center. So this is regarding to the exactly the same working of this one. Okay, so this is regarding to the AND function. So the next thing we need to know, it is called use of logic gates in pneumatic application. So until now we have studied the shuttle wall for the application of extension of the single acting cylinder and the application of twin pressure valve for the extension of single acting cylinder. Now we are combining both OR and AND gate along with a memory device for the control of extension of double acting cylinder. Okay, so in this circuit it mainly consists of two push button operated, spring return, normally closed direction control valve, then it is connected to the shuttle wall, then it is connected to the limit switch, 3/2 spring return direction control valve as the AND gate, then it is connected to the 4/2 direction control valve with pilot operated and this is also called as the memory device. So what is meant by the memory device? The memory device which keep the control system for at a particular state until the reverse signal is activated. So here this memory device which keep the pressure on the blank end of the cylinder during the extension stroke. Then the cylinder, it is finally connected to the inhibit device for the retraction of the double acting cylinder. Observe here, first initially when push button is operated for valve V1, then this push button valve actuate the valve V1 from normally closed position to the normally open position. Then compressed air will flow from inlet port P to the outlet port A. Then it is enters into the shuttle wall and this will actuate the valve V3. When this compressed air enters into the valve V3, then this ball shifted towards the right side and this will blocks the other input line. Then this pressurized air, it is from the shuttle wall, it is then enters into the AND gate and this will actuate the valve V4. Once it is activated, then it is shifted from normally closed position to the normally open position by pressing the button C. Okay, when this compressed air from the inlet port of the AND gate, it is then enters into the outlet port of the AND gate. From the outlet port of the AND gate, it is then enters into the 4x2 direction control valve. So in the 4x2 direction control valve, it is initially in the normally closed position. Okay, so once it is activated, it is shifted from normally closed position to the normally open position. Now here the compressed air from the port P, it is then enters into the outlet port B and then it is enters into the blank end of the single acting cylinder. Once it is enters into the blank end of the single acting cylinder, then this memory device which keep the pressure on the blank end of the single acting cylinder and this will cause us the extension of double acting cylinder. Once the piston rod is extended at the end of the extension stroke, this piston rod is going to operate the lever L1. Once it activates the lever L1, this inhibit device is activated and this will send the signal to the 4x2 direction control valve. Then pressurized air, it is flow from inlet port P to the inlet port A, then the retraction of the cylinder is going to take place. So this is the use of logic gates with the help of the one OR gate and one AND gate along with the memory device for the extension of double acting cylinder and retraction of double acting cylinder. So this is the first condition. So second one, it is called sequential control of two double acting cylinder using the pneumatic poles. So here it mainly consists of two double acting cylinder, then it consists of two 4x2 pilot operated direction control valve and three lever operated spring return normally closed direction control valves, and then one push button operated spring return normally closed direction control valve and it is connected to the compressor with FRL unit for conditioning the compressed air. Okay. So in operation, when push button is started or when push button is operated, compressed air, then it is passes through the FRL unit and it is then enters into the direction control valve. So once it activates the direction control valve, then so initially the direction control valve in the normally closed condition, whenever it is activated, it is shifted from normally closed condition to the normally open position. Now compressed air will flow from inlet port 1 to the inlet port 2 and then it will send the signal to the valve V2. Whenever it sends the signal to the valve V2, then it sends the compressed air from inlet port P to the outlet port A. Then this compressed air from the outlet port A, it is then enters into the blank end of the cylinder 1 and this will causes the extension of the double acting cylinder 1. So at the end of the extension stroke, this piston rod of the cylinder, it operates the lever L2. Once it operates the lever L2, it actuates the valve V4. Then this valve V4 sends the signal to the valve V5, and this valve V5, it is pilot operated 4x2 direction control valve. Then this sends the signal from inlet port 1 to the outlet port 2, then compressed air from the outlet port 2, it is then enters into the blank end of the double acting cylinder C2. Hence, the extension of the double acting cylinder C2 is going to take place. At the end of the extension stroke, then this piston rod activates the lever L3, and this will send the signal to the valve V6. Then this valve V6 activate the valve V2, then the compressed air, now it will flow from P to B, then this causes the compressed air to flow into the piston rod of the cylinder, and this will causes the retraction of the cylinder. So during the retraction or at the end of the retraction stroke, this piston rod, it activates the or pushes the lever L1. So because of this L1 activates the valve V3, then this valve V3, it sends the signal to the for valve V5. This valve V5 allows the compressed air now to flow from inlet port 1 to the outlet port 4, and this will send the compressed air into the piston rod side. Then the retraction of the double acting cylinder is going to take place. So this will implies that here the sequential control of two double acting cylinder with the extension and retraction stroke. Thank you.